Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.120. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and I2 for this particular circuit using current divider rule is provided here. We also will be using parallel equivalent resistance calculation formula. R equivalent of two parallel connected resistances is calculated by taking the product of both resistances dividing by their sum. Now move towards the problem. Exercise problem number 2.120. A typical transistor amplifier is shown in given below figure. Find the amplifier gain G. This is the circuit diagram of given problem. Inside this network we have to find the gain of this transistor. As it is given in this scenario, gain is the ratio of output voltage and input voltage. In this case, input voltage is provided but output voltage is not given. So first we have to solve this network in order to calculate output voltage. Whenever we will be having output voltage, gain of this transistor amplifier will be calculated easily. For the calculation of output voltage, we should have the value of current through this resistance. And for the value of current through this resistance, we should have the value of voltage across this dependent voltage source, that is 4 multiplied by 10 raised power 5 times IB. IB is the base current. So in short, we should have the value of current IB. After that, we will calculate from this IB voltage across this dependent voltage source, and this dependent voltage source will be utilized to calculate voltage across this 300 ohm resistance. So first of all, we will try to find out the value of current IB through this 500 ohm resistance. In order to calculate base current through this 500 ohm resistance, we should have the value of total supplied current through this voltage source. Later on, we will apply current divider rule to calculate current through this branch, that will be equal to IB. These two resistances are connected in parallel connection. So in order to calculate total supplied current, we have to find their equivalent resistance and replace these two resistances with a single resistance so that the circuit convert into a simple series network. So R equivalent of these resistances will be calculated by taking the product of both resistances dividing by their sum. R equivalent of this connection will be 454.55 ohm. Now we can replace these two resistances with a single resistance having the value of 454.55 ohm. This circuit is converted into a simple series network, so we can calculate current through it using Ohm's law. Current through this network will be equal to 250 millivolt divided by the total resistance of this network, that is the sum of 100 ohm and 454.55 ohm. So the value of current will be 450.82 microampere. And the direction of current will be clockwise direction, leaving from positive terminal and entering towards negative terminal. Now we have calculated this branch current that will act as total supplied current. So we will move back to our original circuit to calculate current through this branch using current divider rule. Equation for current IB using current divider rule will be equal to the product of opposite branch resistance and total supplied current divided by the sum of both resistances. So the value of current IB will be equal to 409.84 microampere. We have calculated the value of current. Now we are able to calculate voltage across this dependent voltage source, that is 4 multiplied by 10 raised power 5 times IB. So the value of voltage across this dependent source will be 163.936 volt. After calculating voltage across this dependent source, we can calculate current through this closed loop using Ohm's law. Current through this closed loop will be equal to 163.936 volt divided by the sum of both resistances that are connected in series connection. So the value of output current through this network will be 38.12 milliampere, and the direction of this current will be counterclockwise, leaving from positive terminal and entering towards negative terminal. Now we can calculate voltage V0 using Ohm's law because current through this 300 ohm resistance is known. So voltage V0 will be the product of current through it, that is 38.12 milliampere, and the value of resistance 300 ohm. Here minus sign is taken because current is entering from negative terminal of output voltage. So the value of output voltage will be minus 11.44 volt. We have successfully calculated output voltage of this amplifier network. So now we can calculate the gain of amplifier by dividing output voltage with input voltage. So gain of the amplifier will be equal to minus 11.44 volt divided by 250 millivolt. So the gain of this amplifier will be minus 45.76. So this was exercise problem number 2.120. Thank you. See you again in next video.